On this one? All right, leave that up for a few more seconds. Alright, so now we're going to look at adding and subtracting our rational expressions. We're still writing. Alright. There we go. Okay, so first we're going to look at when you have a common denominator or your like denominator. Okay. And again, the same rules for regular ordinary fractions and adding them apply here. Okay, so let's say if you remember, if we wanted to add, let's say 3 over 11 plus 5 over 11. Okay, so we knew automatically looking at it, you had like denominators, same denominator. Okay, so as long as the denominators are the same, we know something over 11 plus something over 11, your answer is going to be something over 11. So all we have to do now is just add our numerators. So just 3 plus 5. Which gives us 8 over 11. Okay. So if we had two rational expressions, we do the exact same thing. Nothing changed. So let's say, for example, we wanted to add x over 8 plus 3x over 8. Oops, straighten that up a little. Okay, so for that one, x over 8 plus 3x over 8, you can see you have the same denominator. So that means something over 8 plus something over 8 is going to give us something over 8. All we have to do is add our numerators. So it's just x plus 3x. Okay. So if we add them together, we end up with 4x over 8, where 4 divided by 4 is 1. 8 divided by 4 is 2. So we end up with x over 2. All right. Any questions on that one? All right. So let's say if we have, let's move that up a little bit. If we wanted to add 4s plus, well, minus 9 over 9t plus 7 over 9t. And so the s isn't mistaken for a 5. I'll just draw a line through it. Okay, move this up a little bit. Okay, so our 4s minus 9 over 9t plus 7 over 9t, we see we have our same denominator. So that means our answer is going to be something over 9t. So now all we have to do is just add our numerators. Okay, so up here, you had just one term, so you didn't have to worry about anything. So whenever you have more than one term, just out of habit, always put them in parentheses, and you'll see why in the next example. So 4s minus 9 plus 7. Okay, so this one just being positive, that just becomes 4s, and then you can combine those two. So negative 9 plus 7 is negative 2 over 9t. Or if you wanted to, you could factor a 2 out of both of those and have 2s minus 1 over 9t. That should be okay, but on the exam, if it's multiple choice and you don't see this answer, you'll probably see this one. So you'll see one of them. All right, any questions on that one? All right, leave that up for a few seconds. So let's say, for example, move that up some. We wanted to subtract. Say x squared plus 10x over x plus 3 minus 4x minus 9 over x plus 3. All right, so just like before, over x plus 3 minus 4x minus 9 over x plus 3, we see we have the same denominator. Which means your answer is going to be something over x plus 3. Okay, so that means you just subtract your numerator. So you have x squared plus 10x minus 4x minus 9. And this is why I always use the parentheses, because a lot of times what people do is they'll just say minus 4x minus 9, which would be wrong because you're subtracting that entire second numerator. So if you're subtracting that entire second numerator, you can't forget that that negative applies to the minus 9 also. So that's why you want to put the parentheses there. Now once you do that, you just have x squared plus 10x. Now we can go ahead and distribute that negative to both of them. So you have minus 4x plus 9 all over x plus 3. Okay, so these two terms, we can just go ahead and combine those. And that gives us x squared plus 6x plus 9 over x plus 3. Okay, which looks like you're done, but you always want to make sure. So whenever you're left with a polynomial, you always want to factor just to make sure anything can cancel out. So we know that x squared plus 6x plus 9, our b is equal to 6, and our c is equal to 9. You don't have anything in front of the x squared, so you can just do the direct factoring approach, where you find two numbers that multiply to equal your c, and those same two numbers add to equal your b. I'll give that a little more space. Okay. So in this case, you can use 3 and 3. That works. because 3 times 3 is 9, and 3 plus 3 is 6. So that means this just factors to become x plus 3 times x plus 3. Okay. Now you also could have used the perfect square trinomial, but that just been extra work. Because you have x squared, and you have 3 squared. If you have 2ab, that becomes 6 squared, so you could have done that also. Okay, so that means your x squared plus 6x plus 9 can be factored to be x plus 3 times x plus 3 over x plus 3. Okay. Now, if you wanted to, you can rewrite the numerator. You don't have to, but sometimes you can feel better doing it as 1 times x plus 3. Okay. And these two or those two can cancel out. So you have x plus 3 over 1, which leaves you with the final answer of x plus 3. Okay. So even if it looks like you're done, try to factor it and see if anything can cancel out. All right. Any questions on this one? All right. I'll leave that up for a few more seconds. Alright, so now we're going to go into adding and subtracting with unlike denominators. Adding, subtracting with unlike denominators. Okay, so just like before, we're going to compare them to how we handle just regular ordinary fractions. So let's say if we have 3 over 8 plus 1 over 6. Okay, so the first thing you want to do is you want to find your least common denominator. Okay, so there are actually multiple ways you can do that. But the one way I always found was easiest is with 8. You know that's 2 times 2 times 2. And 6 is 2 times 3. Okay, so if we rewrite it to 3, and instead of 3 over 8, make it 3 over 2 times 2 times 2, plus, instead of 1 over 6, make it 1 over 2 times 3. Okay. So now we have to make both of these denominators equal. So you have a 2 over here and a 2 over here. The only thing is, now you have 2 2's over here, but you don't have 2 extra 2's over here. So you're missing a 2 times 2, or you can just put 4. Okay. So here you have a 3 over here, but you don't have a 3 over here. So this side you're actually missing a 3. Okay, so to match those up, give it a little bit of space. So 3 over 2 times 2 times 2 plus 1 over 2 times 3. You go ahead and match those up. Since we're missing a 3 over here, you want to multiply it by 3, but you can't just do the denominator. Anything you do to the denominator, you have to do to the numerator. So you multiply by 3 over 3. Bless you. And here, since you're missing a 2 times 2, you multiply this one by 2 times 2. But anything you do at the denominator, you have to do up top. So it's 2 times 2 up there. Okay. So now we have 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. So the denominators both match up. Okay, so now the denominators match up. You have 3 times 3, which is 9. Over 2 times 2 times 2 is 8. 8 times 3 is 24. Plus 2 times 2 is 4. 2 times 2 times 2 times 3. We already know that's 24. So we have 13 over 24. Since we have our same denominator. All right, so any questions on that one? Like I said, that's just one of whatever many methods you want to use. But to me, that was always the easiest way to do it. Okay, so we're going to apply those very same steps to adding and subtracting your rational expressions. Excuse me. Oh, do you have a question? Or are you just stretching?
I was stretching.
Oh, okay.
I do have a question.
Sure.
Now, what if it was a larger number and you had more students, like maybe you had a 10 students, you have to write them all out?
Oh no, you don't have to write them all out. All you have to do is just write them out to where you can match them up. So if you have 8s, you can just leave them as 8s. If you have 16s, you can leave them as 16s and just match them up that way. All right, so let's say, for example, here, we just want to find the least common denominator. Find the least common denominator of each pair. Okay, so let's say for problem A, we have 1 over 8 and 3 over 22. And let's say for problem B, we have 7 over 5x and 6 over 15x squared. Make that 1 look a little more like a 1. There we go. Okay, so for problem A, you have 1 over 8. You have 3 over 22. We know that 8 is just 2 times 2 times 2. And 22 is just 2 times 11. Okay, so if we go ahead and just rewrite these two, instead of 1 over 8, we get 1 over 2 times 2 times 2. And 3 over 22, we can make it 3 over 2 times 11. Okay, so now we just go ahead and match both of them up. We have a 2 here, we have a 2 here. We have 2 2's over here, but we don't have additional 2's over here. So we know on this side, you're missing the 2 times 2. Okay. Now we have an 11 over here, but we don't have an 11 over here. So on this side, we're missing an 11. Okay. So that just means we have to rewrite it. And that becomes, let's give it a little bit of space, 1 over 2 times 2 times 2. And 3 over 2 times 11. Okay. So we know in this one we're missing our 11. So we just multiply this by 11 over 11. And this side we're missing our 2 times 2. So we multiply this one by 2 times 2 over 2 times 2. And again, if you wanted to make this 4 times 2, you could have. That would have been okay too. I just like to break it down as prime numbers for some odd reason. Okay, so you have 2 times 2 times 2 times 11, 2 times 2 times 2 times 11, so both of your denominators now match. So that means your denominator, or your least common denominator, would be your 2 times 2 times 2 times 11. 2 times 2 is 4, 4 times 2 is 8, 8 times 11 is 88. Okay, so that would be your least common denominator. Yes?
Is that just an easier way for you to learn to figure out the LCD?
Yep, that's just, yep, just a way to do it. Like I said, it's just one way to do it. You may go on the internet and find 10 other different ways that might be easier.
So it's just easier to figure out what the LCD is, multiply, and then rewrite the...
At least for me it is, and the way I've taught it this way, people said it was easier. But like I said, somebody may say, well, I did it this way and it was easier for me. It's, like I said, it's all a matter of preference. All right. Any other questions? All right, so let's do B. And actually, if you have variables, it's a little bit easier. And then move that up a little bit. So for B, you have 7 over 5x and 6 over 15x squared, where we know that your 5x is just 5 times x. And straighten that up. And 15x squared is just 3 times 5 times x times x. So if we rewrite this, you have 7 over 5 times x, and you have 6 over 3 times 5 times x times x. Running out of paper, so we're just going to write in what's missing. Here, we know you're missing, well, we have a 5 here and a 5 there. We have an x here and an x there. But here you have a 3 and you have an x over here, but you don't have it over here. So you're missing a 3x. So you're missing 3 times x. And let me kind of box that off a little bit. Okay, so you have 7 over 5 times x. Give that a little more room. And 6 over 3 times 5 times x times x. We're missing our 3 times x, so that means you multiply this one by 3 times x over 3 times x. So you have 3 times x times 5 times x, 3 times x times 5 times x, so they both match up. So that means your least common denominator, which is 3 times x times 5 times x, order doesn't really matter, which is 15x squared. All right, any questions on that one? Bless you. All right, I'll leave that up there for a few more seconds. Looks like everyone's done writing. Okay, so let's say if we wanted to find the least common denominator of, say, 6m over 3m plus 15 and 2 over m plus 5 squared. Straighten that up. Okay, so the first thing you want to do, you want to factor both of your denominators. Okay, so the 3m plus 15, you can factor a 3 out of both of those. That leaves you 6m over 3. 3 times m will give you 3m. And 3 times 5 will give you 15. Okay, so we factored that one. And the next one, 2, m plus 5 squared, that's just m plus 5 times m plus 5. Okay, so both of those are factored. Okay, so now we just match them up. We see what's missing in one and what's missing in the other. So this, you have an m plus 5, you have an m plus 5. Here, you have a second m plus 5, but you don't have it over here. So we know this side is missing an m plus 5. Okay, so now here, you have a 3 over here, but you don't have a 3 over here. So this side is missing a 3. Okay, so that means if you have your 6m over 3 times m plus 5, and I'll give that a little bit of room. And we have our 2 over m plus 5 times m plus 5. If this is missing an m plus 5, we multiply it by, I actually didn't need that outside parentheses. That'll just make it look a little messier. Okay, so we multiply this one by m plus 5, but we have to do the same thing to the numerator. And this one, we know we're missing a 3 over here, so we multiply this one by 3, but we do the same thing to the numerator. So we have m plus 5 times m plus 5 times 3, m plus 5 times m plus 5 times 3. So our least common denominator will be m plus 5 times m plus 5. You can put the 3 in the front if you want to, doesn't really matter. Or 3 times m plus 5 squared. Move that up a little bit. All right, any questions on that one? All right, leave that up for a few more seconds. Okay, so I'll give you one. It's kind of a trick question. And that's if, say for example, you wanted to find the least common denominator of, let's say, 2 over x minus 2 and 10 over 2 minus x. Okay, so let's say if we have 2 over x minus 2 and we have 10 over 2 minus x. Remember, we can always flip them around by multiplying it by -1. So if we multiply this one by -1 over -1, then we have 2 over x minus 2. And you have 10, remember that's -10 here, since we multiply by negative.